Hello, welcome. I'm Karthik. I work in the big data team at Uber. I'm here with Bo, also from the same team, to talk about building Uber's Apache Spark compute as a service. Oops. In the first half, we are going to talk a bit about some of the use cases powered by Spark at Uber, the Spark ecosystem that we have at Uber, some of the problems that we have seen, and the reasons why we decided to build this, the Spark compute as a service. In the second half, Bo is going to be talking about some of the observability tools that we have built around Spark and the infrastructure that it is running on, specifically on the Hadoop profiler, which is used to collect metrics about distributed Spark applications. So Spark has really grown in popularity at Uber in the 2 years since we started using it. We have quite a few frameworks at Uber building on top of Spark, and a lot of other teams using those frameworks and Spark by itself to solve a lot of problems for our Uber customers. So some of the frameworks are Michelangelo, a machine learning platform which makes it very easy to build, train, deploy machine learning models at scale. Data Science Workbench is our notebook as a service offering for Uber customers that allows customers to build dashboards very easily, and also allows customers to build Spark analytics on our Hadoop data. Some of the use cases that Spark solves is in Marketplace, we use it for ETA estimation for trips. We use Spark to analyze various signals from a trip, heart braking, etc., to understand driving style. We use natural language processing using Spark for understanding the severity of the incoming support tickets. The Spark team by itself uses Sparks for log analytics, thereby gaining insights into what applications are doing so that we can focus more on the areas that we can improve, and also help customers in letting them know where their applications could perform better. So in terms of numbers, we are a yarn-based batch cluster today. We have over 3,000 nodes in multiple data centers, 2 data centers actually. We have over 500,000 jobs running a week. In terms of cluster utilization, about 50% of our cluster is used for running Hive, which uses Spark as an execution engine. Another 45% of the cluster is used for running Spark workloads, which includes our data ingestion workloads. So if you look at it, almost 95% of the 3,000 plus node cluster is just for running Spark applications. So this is the ecosystem that we have. So we have multiple cluster managers across multiple data centers managed by multiple different teams. In many cases, engineers build their own clusters to get away from some of the problems that we have too. Peloton is a resource manager that we have built in-house at Uber on top of Mesos, and we are going to talk a bit about it in the later slides. We have multiple versions of Spark with customers bringing their own versions, cherry-picking patches from the open source community to solve some of our problems. We have multiple authentication mechanisms in our clusters, with Uber having its own specific authentication mechanism as well. We are heavily dependent on gateway servers for our development and ad hoc analytics. We have multiple consumption interfaces, and we have many folks from different varied facets using Spark, engineers, data scientists alike. All this varied ecosystem presented to us some interesting opportunities, and also brought out some of the problems that we have and gaps in our infrastructure. For example, developers typically complain about tooling. With the number of applications that we are running, the history server does not scale very well. So we had to tune it to get it to working in a good state. If customers cannot search for applications, the history server does not work reliably, does not load applications and such. The number of applications also gives us problems with our HDFS storage. For example, we have the problem of a large number of very small files, which puts a lot of pressure on our HDFS that we use in the HDFS name node that we use for storing our logs. Customers are asking for build and deployment tools because they keep reinventing it over the course of time, and they ask for best practices in how they can actually achieve this. They are looking for better profiling tools to understand their Spark applications, so that in turn they can make them more efficient. We have terrible guarantees with the SLAs for our gateway machines because these are shared resources. A lot of people are using it. There are large processes, so they get killed very frequently. With the number of clusters that we have, the different Spark versions that we have, it's hard for customers to discover the actual set of tooling that each of these clusters have for running their Spark applications. Not just tooling, configurations, which cluster to run on, all of them, discoverability becomes a problem. Dependency management, specifically for Spark applications, has been a problem with different teams coming in with different versions of their dependent packages. As I mentioned before, we are running a shared yarn cluster today. From a cluster operator perspective, we are looking at multiple semi-managed clusters with developers doing the work of cluster operators as well. So this leads to inconsistencies in operating system patch levels, opening us up to vulnerabilities. It also is highly inefficient because when one cluster is not running a lot of jobs, if another cluster is running hard, it's hard for customers to figure out which other cluster they could run on some of their jobs to their cluster. So keeping all these things in mind and wanting to remove some of these problems, we came up with the Spark Compute Service. It was our motivation to make our cluster more efficient and also to improve the lives of developers and make them more productive at Uber. So it was built with these 4 tenets in mind. We wanted to consolidate our infrastructure investments. We want to improve developer experience. We want to serve all the use cases our customers might have and also proliferate the tool sets that we have built so that we can double down on Spark as the batch framework of choice at Uber. So consolidating our infrastructure investments would actually let us to pool in all the hardware resources that we have in various fractured different teams and pool them together for all our customers to use. This helps us do better planning and forecasting for hardware resources for the future. It also allows customers access to more hardware and also more expensive hardware like GPUs. It allows our infrastructure teams to build observability tools, observability and audit tools which are common across the platform and make it available to our customers. We want to improve our developer experience so that they can start working on their code, iterate fast without having to worry about boilerplate stuff. It also gives us the opportunity to leverage in-house expertise in how we build Spark applications and how we write Spark applications and send it out to all our customers using Spark. By serving multiple use cases, which could be exploratory, scheduled batch, bursty batch, whatever that may be, we wanted to provide tools for our customers so that they can manage their entire life cycle. We wanted to keep this experience seamless, irrespective of whichever stage of application development they are in, so that they are used to the same set of tooling across the application life cycle. By proliferating the tool sets, reliable tooling, documentation, various consumption interfaces, we want to accelerate Spark adoption at Uber, and we want them to think of Spark when they're thinking about new batch processing use cases. We want to empower users to go more productive. As I mentioned before, 95% of our cluster utilization is just Spark. Any efficiency improvements there means better efficiency for our entire cluster. So this talks about how a compute service makes all these things possible. One of the things that it does is abstracts the notion of multiple clusters away from the users. So as I mentioned before, we have multiple clusters with different security properties. So one of the clusters is Peloton, and I'm going to introduce that here. So Peloton is a resource manager that we have built at Uber on top of Mesos. At Uber, we have an online fleet which has been over-provisioned so that it can deal with peak traffic. So most of the times, it is not utilized to its max extent. So it gives us an opportunity where we can run resource-constrained batch workloads in this online fleet. So Peloton makes this possible for us by co-locating batch workloads and online services together in a way where the online services are not affected. It also allows for preemption and revocation of jobs. So how this helps is when a job has allocated a resource but is not actually consuming it, Peloton makes this resource available, both memory and CPU, available to another job which is waiting for resource. And when the original job wants to reclaim it, Peloton kicks out the job which was leased this new resource. So the Uber Spark Compute Service is the gateway for managing Spark applications at Uber, be it submission, killing, monitoring, whatever that may be. It makes use of Livi, an open source project used for managing Spark applications using a RESTful interface. We have modified Livi to work with Peloton as well. So customers can use our compute service irrespective of the underlying cluster. In many cases, they wouldn't even have to know that their Spark application is running on Yarn or Peloton. And also Peloton allows for customers to run their Spark applications within the context of a Docker container. So this allows customers to bring in their own dependencies without having to wait or wait on SREs for installing their dependencies in our shared Yarn cluster. Moving over to the architecture, we talked about this a bit. Uber's compute service uses Livi behind the scenes to talk to Yarn or Peloton. Livi supports multiple Spark builds. It also supports for customers to bring in their own builds as well. This makes it very easy for us to build Spark and make all the changes available to all our customers without us having to wait for customers to pick up the new builds. Since we are the gateway of submitting Spark applications, we can inject all the configurations necessary for submitting the application into a specific cluster. Customers do not have to know any of these configurations at all. Since we are the gateway, we have the ability to standardize some of the logging and how metrics are published to other metrics portal that we have at Uber. Observability is one key piece of all the things that we do at Uber. It helps us to be more efficient. It helps our customers to be more efficient. So what Livi or Spark compute service that we have does is to inject the Hadoop profiler, which Bo is going to be talking about a bit more, which injects the Hadoop profiler which captures metrics about what your application has been doing and surfaces these metrics to the user using our observability tools. For example, it captures information about the amount of memory is allotted to your application versus how much memory is actually used. We in turn, the Spark compute service can in turn make use of this application and actually configure these parameters when your application is submitted the next time, without the customers having to change anything in their application settings. We also have a log analytics pipeline which processes logs which is generated from the Spark applications and stored in HDFS so that we can generate insights into what kind of applications customers are running so that we can double down on and implement more tooling around it to make their life more easier, and also to provide some more information to users on where if their application fails, where it fails, if they can be doing something better. So as I mentioned, Uber's Spark compute service is the one-stop shop for accessing all our other tooling at Uber, which allows us to horizontally scale all the other services that we have, which includes the Spark history server and Livi. Bo is going to be talking about Hadoop profiler and the observability tools. Thank you.
Cool. Thanks, Karthik. So my name is Bo. So we're glad to see people here, and we will do some deep dive about the observability we use in Uber for Spark. And we see Spark is so widely used in Uber, and sometimes people come with some common questions, so we try to answer these common questions. For example, for developers, they normally ask how expensive my Spark application is using, and do I use too much resource, or what kind of configuration we should use for my Spark application. And for the cluster-wide operators, so people want to know the trend of all the applications. For example, is all the applications becoming slow, or they becoming using more resource? So what kind of the pattern there? So to answer all these questions, so we decide to build a profiler to get into the system and to answer the common questions. So before we build the profiler, we hit this challenge. As we know, Spark is a massive distributed system, and one cluster may have thousands of servers, and each server will be shared by multiple applications. Each application has multiple processes. So normally for the Java profiler, for example, JProfiler or YouKit, so it's hard to manually attach the profiler to all these processes one by one. It's just a very hard task. So we find some way to automatically attach Java profiler to all the processes. Another thing we noticed is the resource utilization. As Uber, we use Hive Spark a lot, so we just use that as a typical use case, did some analysis. And we find for some Spark applications, as you can see from the second chart, people allocate a lot of resource, but actually only about half of the resource is used. That's a lot of waste. So we need to take the opportunity, and we could improve the efficiency. So this is the profiler we built. So in general, it's a Java agent. So Java, the language itself, provides a mechanism so you can attach a Java agent to each process during the launching time. So in the Java agent, it collects the metrics, for example, CPU and memory through various ways. It uses GMX to get the metrics. Also, it talks to the Linux proc file system to get some more metrics like the ISS or the native memory usage information. It also does some very interesting things. So the profiler can instrument arbitrary Java code and collect how your code is running totally during running time without any code change. For example, it can profile how fast or how long your Java method is running. Also, if your Java method has some argument, it can trace the values of your arguments, and it can print out or send to some data storage. So all this, you don't need to do any code change. You can get that. So after the Hadoop profiler get all these metrics, it has a reporter, so it can send out the metrics. So by default, we implement a Kafka reporter. So you can also implement a database reporter, so it can save to database and you can query. We integrate the profiler with the Uber internal data infrastructure systems. Basically, that's three parts. So the first part is we collect data. That's the Hadoop profiler itself. Then we have the real-time debugging part and the historical data offline analysis part. So normally, after a user finish their Spark application, so they want to know immediately some feedback about their application. For example, do I have data skew in my application? How much memory do I use? And can I reduce? What kind of memory configuration should I use for my Spark application? So this needs to be collected and aggregated in the application level. So we have a Phoenix job. So it listens to the Kafka metrics and calculates all the application level metrics and store that in a database. And we have web UI to show that. Another part is the offline analysis part. So because we have so many machines and we have thousands of applications every day, and normally people want to, especially the manager and our SRE, they want to know, for example, for 1 month, how the application is running. They say, is the resource usage in the cluster, is it close to full, or we still have plenty of resources for future growth? To answer these kind of questions, so we feed the data to HDFS, then we use different SQL query engine, like Hive, Presto, and Spark. We query the online HDFS data, and we have, internally, we have a SQL web UI on top of Hive, Presto, and Spark to answer SQL queries and provide the results. So how we use this profiler? In one word, it's very simple to use it. So when we build it, we try to make it work with Spark without any code change requirement from user side. So here, just some example. So you can just change some configuration and hook up the Hadoop profiler jar file path and some JVM options. And since it's a Java agent, it can work not only with Spark, it can also work with other normal Java application. For example, you have a simple Java program, you can also use this Java agent to collect metrics. And we did that in Uber to help other teams as well. Okay, so after we have this profiler, we did a bunch of use cases. The most common thing is to do memory deep dive. As we know, the memory in Spark is very complex. So the Spark has heap size. The heap memory is very important. Also, it has off heap. And sometimes your Spark application is using native libraries. And this native library will use native memory. And this native memory will not show up in the heap size matrix. So we need to know the real physical memory, which include the native memory size. So that's why we collect a bunch of memory information, so including the heap size, the RSS, and also direct buffer and mapped file buffer. So this can help people to deep dive their Spark application memory usage. So one successful example is inside Uber, we had a very large Spark application. It had 1,000 executors. Originally, it used 7 gigabytes for each executor. So after using Hadoop Profiler, we find, actually we can reduce that number to 5 gigabytes. So for each executor, we save 2 gigabytes. Then for 1,000 executor, the total saving is 2 terabytes of memory. So just by using the Hadoop Profiler, we save so much memory. So another example is Hive on Spark. So as we mentioned just now, so we use Hive on Spark pretty broadly. And we find in our configuration, we find around 70% Hive on Spark queries not fully utilize the resource. So that's a big opportunity. Again, we can get more efficiency and save resource. Yeah, here is some other advanced use cases. So as we mentioned, the Hadoop Profiler can profile your Java code on the fly without any code change. So this is one example. So sometimes we want to audit the Spark application. We want to see what files the Spark application is reading or writing, so we can identify some bad usage or identify some pattern. Again, we don't want user to change their code. So we can just configure Hadoop Profiler with a class name and a method name and argument index. For this particular example, so this is the name node client-side method. So for each Hadoop name node call, it will go to this class. And if you want to write a file, it will call add block to add some content to that file. And the number one means the first argument. So for this method, the first argument is the HDFS file path. So just by configuring like this, we can automatically get all the Hadoop file paths each application is writing. So this is very helpful for us to trace the applications. And some other example is if you don't specify that argument index, if you just specify a class name, it can trace each method call for that. If you just specify a class name and a method name, and the Hadoop Profiler will trace that method call. So it can tell you how long that method takes and how many times that method is called by your Spark application. And we use this to trace our name node latency issue. As we know, when Hadoop has many files, the name node is under pressure. And sometimes people will see high latency when their Spark application make name node calls. So through this configuration, it's very easy to identify that issue and take any action to mitigate. Another part is the flame graph. As we know, flame graph is very useful to identify the hotspot of your application. Normally, generate a flame graph is very tedious. You need to do a lot of tuning and a lot of steps, manual steps to get that. And if you have a Spark application, you have so many processes. So the Hadoop Profiler can also help for that scenario. So it can automatically collect stack traces and send to your reporter. For our case, they send to Kafka. And we have some other script to dump to flame graph, and we can deep dive the CPU hotspot. Cool. So Yeah, that's it. So this is a summary for our whole stuff. So first, Spark is widely used in Uber, and we provide a managed service to help people to use Spark easily. The second is efficiency matters. We also see other talks in today's other session. Many people mentioned tuning, and this is Hadoop Profiler can help you to get metrics before you start to tune your Spark applications. This last one, we are still hiring, and welcome to talk with us. Yeah. Also, yeah, we have several minutes, and we would like to answer any questions. So if you guys have any questions or any suggestion, feedback, so welcome to ask. Yeah. Thank you.
There are microphones in the middle of each aisle. Please come up and speak close to the microphone.
Hello, I have a question. I'm Dan Ballou from Deloitte, and I was just wondering, so the spin-up time for having like 1,000+ nodes, does that slow down the jobs, or does the fact that you're distributing it so much actually make up for the fact that you're distributing these jobs across so many nodes?
Oh, you mean the launch time for the Java agent? Oh,
Yes.
yeah. Yeah, this is a very good point. So we keep the overhead in mind very carefully. So actually, the launch time is very fast because the Java agent, the Java file, is in HDFS. So when Spark job runs, it will download Java from HDFS. So in our configuration, the download part is very fast. And after the launch, another part actually we care about is the runtime overhead. We also measure that. So interesting is we can use the Hadoop profiler to profile the profiler itself. Yeah, because the profiler is just Java code, and we use the profiler to profile its own Java methods, and we can get the latency of each of the main method in the profiler, and the latency is around several milliseconds, and we collect all metrics every minute. That means for every minute, the overhead is in milliseconds level, so it's very small. Yeah.
Thank you.
Okay, you're welcome.
I have a question. You mentioned about preemption in Peloton and how it's different from Yarn preemption.
It's not. However, the version of Yarn that we are running does not have preemption enabled. But we have heavily invested in Mesos for our online fleet. And we are Peloton is also Mesos is something that we are also looking at to run on our cloud infrastructure as well. That's something that we have been investigating. And when we do that, we would be using Peloton as a go-to reference infrastructure for running Spark applications.
Thanks.
Cool. Yeah. If no question, yeah. That's it.
Cool.
Thank you, guys.
Thank you.